So now we will begin chapter 12, which is areas related to circles. By now we already know how to find out the area and perimeter of some simple figures such as a square, a rectangle, a triangle, etc. Now we'll first of all find the same for a circle, because then we need to use it to calculate some special parts of a circle, mainly the segment and the sector. So first let's see, for a square, if I give you one side of the square, what will be the area? It's going to be side square. And what can you say about its perimeter? It will be 4 times the side of your square. Talking about a rectangle, if I give you the length and breadth of my rectangle, the area will be L into B. And what about the perimeter? It will be twice of L plus B. For triangle, there is no fixed way except for the perimeter. Perimeter is sum of all sides of a triangle. So if I give you the 3 sides as A, B, C, the perimeter is equal to A plus B plus C. Talking about the area, it could have been half base into height. We can also make use of Heron's formula, which is under root of S minus A, S minus B, S minus C, where S is the semi-perimeter, that is A plus B plus C by 2. Now talking about a circle, so first let's understand what is a circle. So circle is a two-dimensional figure. Okay, its 3D analog is what we call a sphere. That is 3D. 2D is circle. So whenever I talk of 2D, I talk about a plane. Whenever I talk about 3 dimensions, I always talk about a space in that case. Okay, so for a two-dimensional figure circle, we can say that it is a set of points which are at a fixed distance from a fixed point. That fixed distance, can you tell me what it is? It is the radius of a circle. And what can you say about this fixed point? It is the center of the circle. So when I talk about perimeter, it usually means the sum of all sides in that figure, or basically it refers to the entire boundary of any figure. So for example, if I talk about a square, so these are its sides. So when I calculate the perimeter, I do this side plus this side plus this side plus this side. That gives you 4 times the side, because all sides are equal in a square. So similarly in a circle also, you will be interested in finding out the length of this boundary. Now this boundary is nothing but the circumference of circle. Now this is usually denoted by its first letter C. Now I'll also like to talk about the diameter of a circle. To understand that, you need to know the chord of a circle. So if this is my circle with say center O, then I say that PQ is a chord of the circle, which means it is a line segment joining 2 points on a circle. So this is my chord. So in this way I get my diameter. This is the longest chord of a circle. So this AB is the diameter, it is the longest chord of a circle, and it passes through the center. So this is what we call a diameter. Now if you look carefully, what is OA and what is OB? Okay, these are line segments joining center and the point on the circle. So both of them should be individually equal to R. So diameter can also be represented by its first letter D. So I can say D is equal to R plus R, or in other words I can say D is equal to 2R. So we'll be making use of this relation also very soon. So an alternative definition of circumference is basically the distance covered by traveling around a circle once. So if I'm at this point, and the distance that I'll cover to cover this entire length of circle and come back to this point is what I'm referring to, the circumference of my circle. Now what's so special about this circumference is that it bears a constant ratio with its diameter. Okay, ratio means something upon. So circumference upon diameter is a constant ratio. That ratio is what we are calling pi. It's not the pie that you eat, it is this pi, the Greek letter pi. Okay, that is what is used to denote this ratio. And how do we get circumference from this ratio? So circumference upon diameter. So diameter you know is 2R. That's why I was telling you about the relation between diameter and radius. So circumference upon 2R is equal to pi. So I can say C upon 2R is equal to pi. This 2R can be taken up. So this gives you C as 2 pi R. So this is a very important formula for circumference of circle. In fact, here I can also make another rearrangement. I can write this as pi times 2R. Still it's the same. Now what is this 2R? That is the diameter of a circle. So I can say circumference is equal to 2 pi R, or I can also say C is equal to pi D. So pi is a constant. So I'll give you its value very soon. And if you know this pi, you can easily find out the circumference only if you know the radius or diameter of a circle. That will be good for you. Okay, you'll be good to go in that case. So now we'll talk of pi. So pi is an irrational number. So we studied this in real numbers, that it's the opposite of real numbers. It's the opposite of rational numbers, but still it is a real number. The only difference between a rational and irrational number is that an irrational number cannot be expressed explicitly in the form of a fraction like a rational number can. So what about its decimal expansion? It is non-terminating. So this pi has a very long value. Actually, it's somewhat like 3.142857. It goes on and on and on. And it is non-recurring, it's non-repeating. So we obviously can't use such a big value when we're solving questions. So for practical purposes, we take either of these two values, okay? So we can take 22/7, the fractional value of pi, or we can take 3.14. Usually the question will tell you which value of pi you have to employ. In fact, there have been different estimates for this value of pi. A very famous Indian mathematician, Aryabhat, also gave an approximate value of pi as about 3.1416. So there are several values, but we are mainly interested in these two values. So now let's use these concepts on a real life example. So let me represent my earth like this. Let me make some landmass also here and there. Now what I want you to do is slice this earth into two. This earth is almost like a sphere. So if I divide it into two, I'll get two hemispheres. So like this is my northern hemisphere, this is my southern hemisphere. I choose this southern hemisphere, I isolate it, and I look at its top, the top of this hemisphere. So any hemisphere has a circular top. That means this is a circle, so it would have a radius, it would have some diameter. So if we measure the distance across the equator, or basically the diameter of our earth, so diameter of earth is roughly equal to 12,750 kilometers. It's that long. So using this, we can easily find out the circumference of earth, the entire distance that will take to go around the earth. So how can we do that? How can we find out the circumference of earth? There are two formulas for circumference, right? We have 2 pi r and we have this formula pi d. Now since diameter is provided to me, so it makes sense to use this formula. So pi d. So let me take pi as 22/7. You can take as 3.14 as well. And the diameter, you just multiply it with that, 712,750. Okay. So when you solve this, your answer would be roughly 40,035 kilometers. So see, that's why it takes very long for you to go on a world tour, or if you literally go from one point on the earth, cross every mile and then return to the same point, it will take you very long because this distance is actually huge. Then you have to be very careful of one thing, that whenever we talk of circumference, it's basically a distance. So whatever unit of radius and diameter you're having, the same unit you'll have for circumference. So usually circumference would have units like kilometers, centimeters, meters, etc. Now if you've understood perimeter, let's understand area. So what do we mean by area? In general, it refers to the region occupied in a plane, okay? Because we're referring to 2D figures here, so that's why I'm talking about a plane. So whatever space you're occupying in that plane is what we're calling an area. So let's say we're having this circle. Let me divide it into several parts, and each of these parts is actually called a sector. We'll later see what a sector means in detail. So that way I can say that my circle has been divided into almost 16 parts over here, or 16 sectors. Now what I'm going to do is I'm going to rearrange these parts. How? I'll take each of these parts outside from this circle, okay? I'll take them outside, and then I'll take all the odd number parts like 1, 3, 5, 7, and I'll arrange them horizontally like this, okay, in an inverted triangle form. So this is 1, 3, 5, 7, and so on, okay? It goes on. And what do I do with these even number sectors or even number parts? I place them in between the cavities of these odd number parts. So like my 2 would come here, my 4 would come here, 6 would come here, like that. So this would give you a more compact rearrangement, and if you look carefully, it looks like a tilted rectangle right now. So let's make it upright, let's make it erect. So this is almost like a rectangle. Now any rectangle has a length and it has a breadth. Now breadth is very easy to find in this case. If you notice, this is breadth and this is nothing but the line segment joining the center of the circle and any point on the circle. So this is what we are calling the radius. So breadth is radius in this case. What can you say about the length of this rectangle? If you notice here, half of the parts have vanished from the circle because we've placed them in between the cavities of these parts, odd number parts. So that way it's almost, we can say, half of the boundary of the circle, which is half times the circumference of circle. So half times circumference, what is the circumference of a circle? 2 pi r. So area of circle has now become area of rectangle. So area of rectangle is length into breadth. What is the length here? Half into 2 pi r into what is the breadth here? R. So this 2 cancels. You get pi r into r. What is r into r? That is r square. So this is the formula for area. So be very careful. For circumference it was pi times 2r, and for area it is pi times r square. So a little difference of 2 can make you go haywire. So please don't do those mistakes here. One another thing here is that circumference has the unit same as distance, but area has the units distance square. So if my circumference is centimeter, the corresponding area would be in centimeter square. If circumference is in meters, so this will be meter square. If this is in kilometers, this would be kilometer square. So now I present before you a very tasty example. So let's order a regular pizza. You feel free to add toppings of your own. And now if I look at this pizza carefully, it is also almost like a circle, right? So if I give you the radius of this pizza, you can easily find out its circumference and area. So before you eat it, let's first quickly calculate these two parameters for my circle. So let's say it's a pizza of radius 20 centimeters. So I give you a minute to calculate its circumference and its area. So basically r is given to me as 20 centimeters. So circumference will be 2 pi r. So you can take 3.14 value for pi, and r is 20. So the unit will be centimeters in the end, and your answer will be somewhat like 125.6 centimeters. Now let's calculate area. So that will be pi r square. So 3.14 into 20 into 20. So centimeter into centimeter, so the unit will be centimeter square. So when you solve this, you will get almost your answer as 1256 centimeter square, 1256. So you can actually spot any circle in your place and just find out its radius. It will be enough to calculate the circumference and area of that object. So now here we have an example. Before we discuss this example, I'd like to tell you that whenever we talk about fencing, it refers to the computation of the perimeter of that figure, and plowing means you have to calculate the area of that figure. It will definitely involve area in some way, plowing, and fencing will definitely involve perimeter in some or the other way. So because fencing, when we do, you refer to the boundary. You don't fence the entire place, you fence the boundary. And when you do plowing, you do it in the region which has been occupied by your object. So here the figure is a circle. You've been given a circular field. So the total cost of fencing is rupees 5280. So the unit of this total cost is rupees, and then you've been given the rate per meter. So this is cost per meter. So its unit will also be rupees upon meter. So I don't know the radius right now. Now fencing involves perimeter, which in case of a circle is nothing but the circumference. So length of my circular field, if I have to calculate, because that is to be fenced, it's basically to say circumference of my circle. So you know only two formulas for circle right now, pi d or 2 pi r, and unfortunately none of them would work over here. Here you need to make use of your unitary method knowledge, because radius is not known to you. So if you know the total cost of fencing and you know the cost per meter of fencing, dividing the two will give you the total length of circular field, which is basically the circumference of my circle. So you have to do rupees 5280, and this will be rupees 24 per meter. So when you solve for this, your answer will be 220 meters. So the unit will be meters because we are referring to length, and anyways rupees unit cancels and meter will go up, so meters. Now the field is to be plowed at this rate. So rate per meter square for plowing is given to you. The total cost of plowing is not known to you. So again, total cost of plowing total cost of flowing will be equal to what? It will be the area of my circle multiplied by the cost of flowing per meter square. So I know the cost per meter square, but I don't know the area of circle. For area of circle, I know only one formula, that is pi r square. But for that, I require radius that is not given to me. But knowing the circumference, I can find out the radius. So C is given to me as 220 meters. You know circumference is what? 2 pi r. So this is equal to 220. Now which value of pi do you have to use? It is given in the question, 22 by 7. So 2 into 22 by 7 into r is equal to 220. This goes like this. So on solving, you get r as 35. What will be the unit? Meter, because throughout we are talking about the unit being meters. So if you know radius, can you find out the area of this circle? So area of circle is equal to pi r square. Which value of pi? 22 by 7. R is what? 35. So 35 into 35, 7 5s up. And when you solve for this area of circle, you'll get your answer as 3850 meters square. So total cost of flowing will be 3850 meters square into 0.50. That is the cost per meter square. So when you solve for this, your answer will turn out to be rupees 1925. So this is the total cost of flowing the field. So this was so interesting, like one clue led to the other. So we just knew the cost of fencing and the cost per meter. That helped us calculate circumference. So from circumference, we calculated radius. From radius, area. From area and rate per meter square, we found out the total cost of flowing the field. Okay, so now we move on to the actual topics that we need to discuss, the area of sector and segment of a circle. So first of all, let's understand what do we mean by sector of a circle. So it is basically the region enclosed between two radii and corresponding arc of circle. So let me consider this circle over here. A circle will obviously have a center. So let me call that center O. Now region between the two radii. So let me take two radii. Radii is plural of radius. So let me take one radius OA. Let me take one radius OB. Obviously they will be equal in length. Radii are equal. And let me take this corresponding arc, this curved region. Okay. Let me take this arc. So the region enclosed between these two radii OA and OB and this arc AB, this shaded region would be the sector of my circle. Now if you notice carefully, what can you say about this remaining part? This is also bound by two radii and here this arc is very big. That's the only difference. So this arc can actually make a huge difference. This is also a sector actually, because here also you're having two radii and you're having an arc. So if both are sectors, how do we differentiate between them? So you look at the area of that sector. So here you clearly see that this sector is occupying lesser area in the circle. So we call this as a minor sector and this is called a major sector. So obviously from the figure itself you can make out that minor plus this major sector, they would give you your entire circle. Okay, so if I know area of minor and major sector, if I sum them up, I'll get my area of circle. Similarly, if I know the length of this arc of minor sector and length of arc of major sector, if I add them, I'll get the circumference of my circle. So now a very defining property of sector is its angle, the angle which it makes at the center. So let's say here we are having a circle with center O. I'm having these two radii OA and OB, and this is my arc APB. So the area enclosed between this, so that is the minor sector here. So in this case, OAPB is what? It is the minor sector. What can you say about OAQB in that case? It will be the major sector. So now I told you that the angle is a very defining property for a sector. So this is the angle that we are talking about. Okay, the angle between the two radii which is being formed and it's facing the circumference of the circle. So this angle theta. So why is it important? Because it will help you find out the area of a sector. So I can say that my circle is also a sector, but of angle 360 degree. Okay, in a way, if I take this entire angle 360 degree, okay, you will always get a circle. Try constructing this angle for yourself. You'll always end up with a circle. So we can say that sector with angle equal to 360 degree has area what? Same as that of circles, that will be pi r square. So sector having angle equal to 1 degree will have how much area? Pi r square by 360. Sector having angle equal to theta would have how much area? Pi r square upon 360 into theta. I just made use of my unitary method knowledge, and that's how we got the sector with angle theta having this area, theta upon 360 into pi r square. So please remember this formula. Now this is obviously the area of sector with angle theta, which means this is a minor sector. Can you find out the area of the major sector? Yes, you can. By the way, what will be the angle for major sector? So if this angle is theta, this angle will be 360 minus theta, because sum of angles about a point is equal to 360 degree. So like you know, sum of angles in a triangle is 180 degree. You remember this formula also, that sum of angles about a point is equal to 360 degree. So if this angle is theta, this is 360 minus theta. This is the area of your major sector. Okay, for there, this angle you will require. So instead of theta, if you write 360 minus theta, you will get area of major sector. So now what if I put this angle value as 360 degree? In that case, you will be getting your area of sector as 360 by 360 into pi r square. That is pi r square. So pi r square is what? Actually area of my circle. So that's why I'm saying that area of a sector having angle 360 degrees same as area of circle pi r square. All this being said, what will be the units of area? There will also be distance square, so meter square, centimeter square, kilometer square, etc. Now let's do a quick calculation for area of major sector as well. So area of minor sector plus area of major sector will be what? Area of circle. I discussed that a couple of minutes ago as well. So area of minor sector we know is theta upon 360 into pi r square. This area we don't know. A major, let me call this. What is area of circle? That is pi r square. So by that I get A major as pi r square minus theta upon 360 into pi r square. Can you pull out something common? Yes, that is pi r square. So you will get 1 minus theta upon 360. You can take the LCM as well. You will get pi r square 360 minus theta upon 360 over here. So this is another formula for area of major sector. If you can remember it, very good. If not, then you can definitely remember this procedure by which you can calculate area of major sector. Now, if you know the area of a sector, now let's move on to the length of arc. So, any sector has two defining properties. The most defining property is definitely the angle, but we also have this corresponding arc, APB. You can find out its length as well. So, I just told you that circle is like a sector, but here the angle is 360 degree. That's the only thing. So, if my sector with angle equal to 360 degree has length of arc as 2 pi r. So basically length of arc for a circle is the circumference of the circle, the entire arc. So by unitary method we can find out sector having angle 1 degree. What will be the length of arc for that? It will be 2 pi r upon 360. So what if I give you a sector having angle equal to theta, because here my minor sector has angle theta, right? So it will be 2 pi r upon 360 into theta. So this is your formula for length of arc of sector angle theta, theta upon 360 into 2 pi r. Here also if you again put theta as 360, you will get your length of arc as 2 pi r. Why? Because 360 degree means you're talking about a circle, and there the length of arc is nothing but the circumference of the circle. So now we move on to the segment. So what is segment? It is the portion of the circular region. So both sector and segment are a part of a circle only. But here the thing is that it is enclosed between a chord. Chord is any line segment which joins any two points on a circle. So here AB is a chord. And the corresponding arc over here is what? APB. So this region between your chord and arc is what we are calling the segment. Okay, so remember sector was also a part of circular region. Segment is also a part of circular region. But here the region was between two radii and the corresponding arc, and here the region is between a chord and an arc. Okay, here also if I join this OA and OB, you'll ultimately get a sector only if you look. And this sector is having this segment. So we can say segment is a part of a sector in a way. Okay, so here also if you look, this segment will have two parts. Okay, basically any circle can be written as a minus segment and a major segment depending on the area it occupies. So like this is my minus segment and this greater area is my major segment. So here OAPB and OAQB. So this is minor and this is your major segment. So now we understand how we can find out the area of a segment. So I told you that segment is basically a part of sector only, a subpart of sector. So if you look over here, we have a circle with center O. We have these two radii, OA and OB, and APB is the corresponding arc. So OAPB in itself is a minor sector, which is making an angle theta at the center of the circle. And if I look at my sector, the only thing which differentiates it from a triangle is that a triangle has the base as a straight line. But here the base is not a straight line, it's a curved arc. So if I just clip this part, what will I get? I will get a triangle. So basically I can say that my sector is equal to a triangle plus this curved region. Now this region is what? Chord and arc. So the region between them is actually a segment. So that's why I'm saying again and again that segment is a part of a sector, okay, to which you're adding triangle. So if I want to find out the area of this segment APB, you just find out the area of this sector and subtract the area of this triangle from here. Now you already know what is the area of this sector, that is theta upon 360 into pi r square, and then you have minus area of triangle. So now there are different ways to find out this area. You can use half base into height formula. You can make use of Heron's formula, which is under root of s, s minus a, s minus b, s minus c, okay. And here S is the semi-perimeter, that is A plus B plus C by 2. ABC are the sides of a triangle. There are different ways to find this area of triangle, and that's how you'll get area of a segment. Okay, so this is a minor segment. If I want to find out the area of major segment, how would I go about it? So area of minor segment plus area of major segment is equal to area of circle. Now you already know that area of circle is pi r square. We've just seen how you can calculate the area of minor segment. So you'll be able to just substitute these two areas, and that's how you'll get the area of your major segment. Because minor and major segment together make up your entire circle. Now in the question, usually it won't be mentioned which sector or which segment they're talking about, okay, if it's minor or major. So by convention, we take it to be minor only, okay, both sector and segment, okay. So by default, we'll be taking sector and segment to be minor unless they specify in the question what they're referring to. So now we have two examples on sector and segment. So find the area of the sector of a circle. So this is a circle. What is its center? Its center is O. Its radius is 4 centimeters, which means OA and OB is 4 centimeter. So this is my radius, and angle is 30 degree. That means this angle AOB is 30 degrees. So this is my theta. You have to find the area of the corresponding major sector as well, and you have to use pi as 3.14. So what is the minor sector here? This shaded region is actually the minor sector. So let's quickly find out area of minor sector. What was the formula to find out? It was theta upon 360 into pi r square. So what is my theta over here? That is 30 degree. Upon 360 into pi, you have to take as 3.14 into r square, means r into r, so 4 into 4. So when you solve for this, you'll get your answer roughly equal to 4.19 centimeters square. Why unit square? Because it's area, and why centimeters? Because area's unit depends on the unit of your radius. So that is in centimeters, that's why this is in centimeters square. Now how will you find out the area of major sector? This is the major sector. So I told you that minor sector plus major sector make up your circle. So to find out the area of major sector, you can do area of circle minus area of minor sector. So here you know what is area of circle, that is pi r square, minus what is your area of minor sector, that is pi r square theta upon 360. So if you remember that formula, it's good you could have used it directly. Now it will just require 2-3 more steps to derive this formula, that's it. So if you take the LCM and everything, it will be pi r square 360 minus theta upon 360. Now here pi is 3.14, r square will be 4 square. Inside you'll have 360 minus theta, that is 30 degree upon 360. So when you solve for this, your area of major sector will become roughly equal to 46.1 centimeters square. So this is your area of minor sector and this is your area of major sector. It was a very direct question. So now this question is a bit lengthy, but it's not difficult, don't worry. So you have been given a segment now. So we say bye to the sector, now we are moving on to a segment. So here, can you identify the segment though? That is the shaded region only, this AYB. And the radius of the circle is given to you as 21 centimeters. The angle theta is given to you as 120 degree. Pi you have to take as 22/7. Now how do we find out area of segment? For this you require two more areas. You require area of a sector and area of a triangle. Now what is the sector over here? AOBY is just sector. It is a minor sector. Can you find out its area? Area of sector AOBY. What will that be equal to? Theta upon 360 into pi r square. So theta here is 120. So 120 upon 360 into pi you have to take as 22/7 into r square means r into r, that is 21 into 21. So when you solve for this, you will get 462 centimeters square. So it will be centimeters square because radius is in centimeters. So this you've calculated. Now for area of triangle, you need to do a bit of construction work as well here. The thing is that here you can't make use of your Heron's formula because only two sides are known to you. It's not even a right angle triangle, so we can't use half base into height formula. And the only way is to make use of trigonometry and few constructions now. So I would prefer using the formula area of triangle as half base into height. But the thing is, I don't have a height. So for that, I'll drop a perpendicular from O on the side AB. So let me call this perpendicular OM. Okay. So the construction involved is draw OM perpendicular to AB. Now perpendicular from center bisects the chord. Okay. It's a property that perpendicular from center bisects the chord. So this is my center O from which I'm dropping perpendicular to actually my chord AB, if you notice. So that means this chord is getting bisected, means it is being divided into two equal parts. That means M is midpoint of AB. M is midpoint of AB. This clue will be very useful when we're finding out the base of this triangle. So if M is midpoint of AB, I can say AM and MB are equal, and I can say that therefore my AB is equal to twice of AM as well. Okay. So now this perpendicular OM is not only bisecting my side AB, OM also bisects the angle AOB. Okay, so this angle is also getting bisected. So this angle is no longer 120 degree. So this will be 60 degree and this will become 60 degree. So now if I draw this triangle over here, this is 60 degree, this is 60 degree, I dropped a perpendicular, so this is 90 each, this is M, this is A, B, this is O, and these are my radii 21 centimeters. So now we are getting two triangles basically. So consider this triangle AMO and triangle MBO. What do you notice here, that this OM side is common. So we just saw that this OM is bisecting this angle AOB. So I can say angle AOM and angle MOB are equal. They are equal to 60 degree because OM bisects angle AOB. OM bisects angle AOB. So now you also look at AO and OB. What can we say about them? That they are also equal to 21 centimeters because they are radii of your circle. So they have to be equal. So if you notice, I'm having one side, the angle, and then another side. So by SAS axiom, we can say that this triangle AMO is congruent to triangle BMO. Okay, now what I wanted to do is assume this OM. Okay, let me take this OM to be X centimeters. So let OM be equal to X centimeters. Now your focus should be on this triangle AMO. Triangle AMO. So now if you make use of cos 60 degree over here, what will you get? What is cos, by the way? It is the adjacent side upon the hypotenuse. So here, what is your adjacent side? That is OM, and hypotenuse is the angle opposite to this angle, that is AO. Cos 60 degree is 1/2. What is OM? We took it to be X. AO is 21 centimeters. So from this you get X as 21/2 centimeters, which gives you your OM as 21/2 centimeters. Now we'll use this to find out AM. Okay, so we have found out the height and we need to find out the base. Okay, so how will I find out AM? I can make use of sine 60 degree here. So sine 60 degree will be perpendicular, or basically the side opposite upon the hypotenuse. So here what is the side opposite? That is AM. The hypotenuse is OA. So sine 60 degrees root 3 by 2, it is equal to AM, that you need to find out, upon OA is 21 centimeters. So when you solve for this, you will get AM as 21 root 3 by 2 centimeters. We found out OM as 21 by 2 centimeters. So this is my height. And how will I find my base? I told you that AB is equal to twice of AM. So we'll make use of this later. So this is the time when we make use of it. So it will be twice of 21 root 3 upon 2. So this becomes 21 root 3 centimeters. So now I'll be able to find out area of my triangle AOB as half base into height. So that will be half AB into OM. So it will be equal to half. What is AB? 21 root 3. What is my OM? 21 by 2. So when you solve for this, 21 into 21 becomes 441. Root 3 by 4. Unit will be centimeters square. But we got so engrossed in finding out the area of triangle that we completely forgot that we actually need to find out the area of this segment. So when I told you that this example is lengthy, I meant that this calculation for area of triangle is very lengthy, truly. So nevertheless, let's find out area of segment. So that will be equal to area of sector, this entire AOIB sector, minus you subtract this triangle AOB now, minus area of triangle AOB. So we calculated this area of sector as 462 centimeters square, minus we will do 441 root 3 upon 2 centimeters square. So when we take some things common and then we solve them, we will ultimately get this area of segment as 21 by 4 into 88 minus 21 root 3 centimeters square. So this is your final answer for area of segment, that is 21 by 4 into 88 minus 21 root 3 centimeters square.